Okay, so the problem we're looking at today is the USACO 2019 US Open Contest Gold Problem 1 of snakes. So you can pause the video first and read through the problem yourself. Okay, I assume you read the problem. So basically, what you're being asked is you're given n groups of snakes. Each group I has size AI, and you're trying to capture them with a net with changeable size. And capturing a group with size AI requires a net to have a size of at least AI as well. And if the size of the net is greater than AI, then the waist is the size of the net minus the size of the group, which is AI. And now you can change the size of the net at most k times, and you want to minimize the cumulative waste after capturing all n groups. So you can pause the video for a second and think about this problem yourself. Okay, I assume you thought about it. So at first glance, this problem just gives off a very, very, very strong DP vibe. So that's what I guess during the contest I thought it must be DP. And I and looking at the size of K and M being both less than or equal to 400, I guessed the state of the DP of Fij equals the first I groups after changing K times the minimum waste. And now, how do we transition? Usually, if we want to transition, we kind of need to know the size of the net after the capturing the first n with k changes, right? But we can't keep track of the size because the size of the group is at most 10 to the 6th power, and we can't afford that, both in space and time. So then what do? Well, in times like this, we have to make bold assumptions. And the assumptions I made here, which is kind of stupid, is if I'm trying to switch at group AI, then I always switch to size. When I'm trying to switch at group I always switch to size AI. That's quite obviously wrong because think about it. If we have, you pull out the drawing board. Okay, so let's say we have a very very big group right here, and then we have here, and then we have a few group right here. Well, obviously, if you have one switch, only one switch, and you decide to switch right here, you're gonna switch to that, right? Because you only have one switch. You're gonna switch to this height instead of the height of AI. That's quite obvious. However, from this very bold and stupid assumption, we can see that if you're trying to capture a group, say from I to J, then the size you're switching to is obviously the maximum between the I and J, right? Which means we can calculate the amount of waste, we can calculate it out by pre-processing. So what does that tell us? Well, since we can't enumerate the size of the net, we can, however, enumerate when's the last time we switched. And if we know when we switched for the last time, we know the size of the net because it'll just be when we switched for the last time and the maximum size between that and I. Because this time we're switching as at I, so we have to capture all the way from, let's say it's L, all the way through group L. Okay, give me a second. Okay, all those are snakes, right? If we're at I right here, and the last time we switched as L, well, it's obviously going to be a maximum size between I and L. That's the size of the net. And then we can calculate the cumulative waste of capturing this whole group with just one net size. And we can pre-process that array. So then the DP transition is going to only have a complexity of ON. So here's my implementation of the algorithm. Obviously, this is the pre-processing. It's pretty easy. I use the array cost ij equals the amount of waste you need to give to capture the group I through j with just one net size. Obviously, it's the maximum, and then you take the maximum minus every single one to find the cumulative waste. Now, the cost of capturing the first group with just one net size is 0, obviously, because you can set the first net size to whatever value you want, and that's the DP transitioning. Every time you enumerate when's the last time we switched the net, and then you have to capture this whole group with just one net size, which can be found using the cost array. And finally, the answer is just the cost of capturing the first n group with k net changes. Okay, so now let's come back to our question today. So this is just basically a simple DP where all you have to notice is that we don't have to actually keep track of the size of the net. We just need to know when we switched for the last time. And I would say this is actually quite easy for a US Open contest, especially for Gold Group. And I was able to solve it within 20 minutes during the mock contest that I did with it. And just FYI, I'm not very good. I'm in silver right now. With the upcoming contest, this I would say is a really easy US Open Gold problem. So hopefully after this video, you'll know how to solve the USACO 2019 US Open Contest Gold Problem 1 of snakes. Thanks for watching.